Good morning. Okay, we're going to jump into our graphs from yesterday. We're going to look at this waves of sine and cosine, and we're actually going to begin to transform them, which is going to challenge us to think back to one of our units before spring break, in which we shifted left, right, up, down, stretched in terms of changing the vertical stretch. We're actually going to not do a horizontal stretch with trig functions this year, primarily because of COVID. So we're going to try to keep this simple, but also productive so that when you go into pre-calc next year, you have exactly what you need to be successful. I'm going to remind you that from yesterday, we started by graphing the sine wave, and I'm going to go pretty quickly through this. But I'm going to encourage you on my YouTube channel, just from past years, I have recorded classes in which I taught something very similar. It's literally called Graphs of Trig Transformations. There's actually 2 years worth, so if you scroll back to 2019, you can see one there. You can also see one from 2018, and you may find that to be super helpful. So you're going to get the simplified version to keep us within our 30-minute time frame that we're allowed to have with you. But if you're just super passionate about trig graphs and you really want to explore more, that's an option for you. All right, so as a quick reminder, we're going to specifically talk about the quadrantal angles that highlight the middle values of sine, the maximum values of sine, and the minimum values of sine. We're going to focus here at first on this first positive x-axis. We're going to label these. We're going to have 0 here. And remember, my x values are my angles, and my y values are my sine. And you already have this in your notes, but I do think it's going to help the more and more you draw it. So if you want to follow along with me, these are yesterday's notes, but you can just draw it again on a sheet of paper. We're going to work our way around the quadrantal angles. There's 2 pi, there's pi. We're going to cut each of these in half. Here's pi over 2, and here's 3 pi over 2. We're also going to go backwards as well. There's negative 2 pi. We're going to cut that in half, and this in half again. And then we're going to remind ourselves that I mentioned yesterday, pi over 2 has a 1.57 decimal value. So if this is 1.57 over, then we'll go a little bit up to be 1 and a little bit down to be negative 1, so that it's a smaller in size compared to the pi over 2. And then we're going to start graphing our sine values. We know that the sine of 0 using the unit circle is 0. The sine of pi over 2, again, we use the y values. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. We're going to say this goes from the middle to the maximum, to the middle, to the minimum, to the middle. I often reference this as middle, high, middle, low, middle. The reason that matters is because that pattern, that rhythm, stays the same. So if we were to go backwards around the circle, my sine of negative pi over 2 is negative 1. My sine of negative pi is 0. Sine of negative 3 pi over 2 is 1. Sine of negative 2 pi is 0. So we go backwards, middle, low, middle, high, middle. This has characteristics to it. We could name that the domain, and I think about just rotating around the circle. I can take the sine of any angular value. My range is from negative 1 to 1, where my maximum is 1 and my minimum is negative 1. We then yesterday went on to graph cosine, following the exact same set of steps in which we highlighted the quadrantal angles. We cut these in half again. And this time I'm going to go even faster. Here's a distance up of 1, a distance down of negative 1, but using my x values for cosine. My angles are here, my cosine values are here. My cosine of 0 is 1. My cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. We say this starts high. I'm going to go backwards as well here. But notice again that the pattern, the rhythm is the same. So if it starts high, right after high is middle, then after middle is low, middle, high. Going backwards, it follows that Whoops, sorry about that. That sits at 3 pi over 2. Same rhythm going back. Now what we're going to do is begin to shift and stretch. Today we're just going to deal with vertical stretches and shifts. Monday we'll tie on horizontal ideas. The vertical is a little bit easier, just like if you remember, if I give you, hey, what is y, if I want to graph y equals, we're going to start with sine because people tend to understand that one better, the sine of x plus 1. In your gut, you realistically know that immediately what's going to happen is my entire sine wave is going to be shifted up 1. So what does that mean for us? Well, what it means is what would have been, go ahead and sketch this, a sine of 0 is now going to be a sine of 0 would normally be 0. It's now going to shift up to 1. And if we cut this in half again, cut this in half again here, we're going to go backwards as well. We're always going to graph 2 full periods. A period is from beginning to end. So middle, high, middle, low, middle is 1 full period. So all we're going to do is, let's go ahead and just even remind ourselves using a dash line. If I've got a cosine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, sine of 2 pi is 0. This would be my normal picture. Well, now we're just going to literally take this entire picture and shift it up. So this is why I started to say, hey, look, the sine of 0 that was 0 is now 1. What was 1 is now 2. What was 0 is now 1. What was negative 1 is now 0. And what is 0 is now 1. Now, there are a lot of you that when I say that, you're probably like, yeah, I get it. But there's some of you who may be like, what? So there are 2 techniques that I think are super helpful to graph transformations. One is to think about if the blue line is the original axis and we take and shift everything up 1, now my green line is my new x-axis. So what would have been here at 0 is now at 1 because it's shifted up. You might be able to see it a little easier that way. So drawing a new axis is helpful, but some of you might like this best. I'm going to consistently ask you for 5 key points. 0, 0. So 5 key points. I'm going to sketch this out. These 5 key points are no different than any other time I've asked you for 5 key points. So there are my 5 parent points of sine. And then remember we talked about what is happening in the mapping. What is happening to get to my new graph? Well, my new graph is shifted up 1. So remember, this was from a while ago. You don't have to do this. You can always resort to this because we're never going to do anything more complicated in terms of needing the mapping. But a lot of you will benefit if you say, hey, I know that I am mapping my points so that there is no change on x, but all my y values are being shifted up 1. So if you remember, and again, I am going to always ask you for ordered pairs. So some of you might be able to read the graph and do that. Others of you may want to do this table instead. I've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0 goes up 1, 1 goes up 1, 0 goes up 1, negative 1 goes up 1, and 0 goes up 1. These are my 5 key points right here. Okay, well, what does that look like for cosine? So let's switch it up and do cosine. Y equals, and a lot of times and on your worksheet, this will be true as well. A lot of times they'll put the vertical shift on the outside. So let's do negative 2 plus cosine of x. Now we're going to need to be thinking about our parent graph that we drew above, but just to be consistent, let's go ahead and sketch it here. Let's get in the habit of labeling. Here's 0, here's 2 pi, cut in half, cut in half, cut in half. We're going backwards as well. Cut in half, cut in half, cut in half. So I know that my original cosine starts high. It goes high, middle, high. It goes backwards as well. I'm going to sketch that with a dashed line. So there's my picture. Now, some of you may be like, okay, that's enough for me to then say, if I move this down 2, because that vertical shift is down 2, what was that green axis there is now going to be here. What started at 1 is now going to start at -1. What went to 0 is now going to go to -2. What was at -1 is now going to be at -3. Some of you may be able to use that axis alone to get my values. But others of you are going to benefit from doing the mapping. There's no change on x, but my y's are going down 2. Now notice my parent points are going to be the same. Or I'm sorry, my parent points are going to be different than sine. They're no longer going to be the exact same, but my y values are going to be different because we've got cosine instead. So we're going to still run these 0 to 2 pi, 0 pi over 2, pi, 3 pi over 2, 2 pi. But now on cosine I start high, middle, low, middle, high. My x values don't move. They're 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now all my y values are going to go down to -1, -2, -3, -2, -1. I now have vertically translated a sine and a cosine. But you may remember too that not only is there a vertical effect of a shift, there also can be a vertical stretch. So we're going to go ahead and put 2 sine of x in front as a reminder. That is a vertical stretch of 2. Let's get our parent graph here. Here's 0, 2 pi. So notice even just in this tiny little set of notes, we're already graphing, what is this, our 5th one. The more you graph, the better. You want to get really good at this. The one thing to remember, and I'll ask you this on Monday, sine graphs, the original parent graph starts in the middle of the wave. Middle, high, middle, low, middle. Going backwards is here. There is my sine wave. Now in your gut, you may be able to look at this and just know that is a vertical stretch. So what would have been at pi over 2 a shift of, or I'm sorry, a distance of 1 up right here, it is now going to be a distance of 2 up. My zeros don't have a stretch, but my -1 is now going to go down to -2. So now my y values have been vertically stretched. Going back this way, I can pick up these points also. But let's say that makes you nervous and you're like, Miss Mann, I don't know that I'm going to be able to name those points. Then let's do a table and a mapping notation. Middle, high, middle, low, middle. My x has no effect. We'll do x effects on Monday. My y values are doubled. So my x values stay the same. And 1 becomes 2, -1 becomes -2. There we go. So the key things that I'm going to ask you to graph on today's worksheet. I'm going to ask you to name what is called the amplitude. When I talk about a vertical stretch, we're talking about an amplitude. Now, I'm going to officially define all this on Monday so that you have really concrete terminology to go along with specifically trig transformations. But we already know how to do some of this. We're going to do a cosine here real quick, but we already knew how to do some of this just simply from our old information. So I want you to be able to get started on practicing this so that you have plenty of time before our test next week. Last one, we're going to go ahead and say, hey, I've got y equals, and this time let's cut the values by a fourth. And we're going to go ahead and graph the parent. We're going to go 0 to 2 pi. Here's pi, cut in half, and we know cosine starts high, middle, low, middle, high, middle, low, middle, high. Now I'm hoping that you're already, just by graphing this along with me, getting a little bit of a rhythm of this. Notice we're going to now look at this value of 1/4 in front of the cosine. Since that's being multiplied, that's a vertical stretch. In this case, it's a vertical shrink of 1/4. So what was up 1 is now up only a fourth. 0 doesn't have an effect by the vertical stretch. What was -1 is -1/4. 0, 1/4. This is a much compressed cosine. I will ask you to, whoops, sorry about that. Let's get that last piece off. I will ask you to give me 5 key points. So make sure if you can read your graph from this and say, oh, well, this is 0, 1/4, pi over 2, 0. If you can read that, fantastic. If you're worried that you can't, then give yourself a 5-point table. Here's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remembering that cosine starts high, then goes middle, low, middle, high. Then we will transform these. There is no effect on the x, but the y is being cut by a fourth. There is no change here, but this is up 1/4, 0, cut to -1/4, 0, 1/4. Okay, I've kept this short. You only have 4 problems to do. When you go and graph these on the actual worksheet, will you do me a favor? Make sure that you are getting in the habit of sketching a graph that provides points. You can either give me a table like this, or you can label the 5 points here. It doesn't matter, but get in the habit of providing 5 points. Also, at the very least, be referencing your parent graph. I think it also helps to sketch it on the graph itself, the way we did here. But you don't have to do that on your homework. And then try to answer the question, what is the range? So for example, if I said, what is the range of this? Hopefully you notice, oh, well now it only goes down to -1/4 and goes up to a fourth. So try to get in the habit of answering those questions too. Again, we're going to highlight some of this more on Monday. The key today is when you go to do the worksheet, make sure you can sketch a picture, getting 5 key points either via table or on the graph itself. I hope you have a great weekend. We're winding down. I'll see you in class on Monday.